So this is session 8. So in this lecture, in this session, we'll be discussing about mobile internet connectivity. So the topics we'll be discussing under mobile internet connectivity are WAP, wireless application protocol, layers of WAP or the protocol architecture of WAP, and then we'll be discussing WAE, wireless application environment, and we'll be discussing WML, wireless markup language script, wireless telephony applications, push architecture, and push and pull services. So these are the topics we'll be discussing in this particular session. Okay. So the learning objective of the session is, after going through the session, the learners will be able to understand the web architecture. They will be able to understand the web application environment. Also, they'll be able to understand like how WML and WML script works in web architecture, and they'll be knowing the web telephony applications and the various push and pull services that are offered through web. So let us proceed. The first topic that we'll be discussing is wireless application protocol. So the growth of the internet applications and mobile communications has led to many early proprietary solutions providing internet services for mobile wireless devices. Okay, because of the growth in the internet, there are many proprietary solutions has been proposed for mobile communications. Okay, so so to avoid incompatible solutions, so there are many solutions. So obviously, if there are many solutions, they will be incompatible, and to ensure that they all become compatible, okay, to avoid any incompatibility, the WAP forum was formed in the year June 1997. This WAP forum was formed by Ericsson, Motorola, Nokia, and Unwired Planet. So these four organizations, they come together and they formed the WAP forum. In summer 2002, the WAP forum, together with Open Mobile Architecture Forum and SyncML initiative, formed the Open Mobile Alliance. They formed a alliance which is called as Open Mobile Alliance. So in short, it is called as OMA. OMA cooperates with many other standardization bodies such as ETSI, GPP. All these are standardization bodies. Okay, so it cooperates with many other standardization body. Okay, so so uh, so and the standards are and they developed the WAP standards, and they developed the WAP standards. Okay, the basic objective of the WAP forum and the OMA are to bring diverse internet content. The basic objective of the web forum and the OMA are to bring diverse internet content, such as web pages, push services, and other data services to mobile phones and other wireless and mobile terminals, such as laptops, PDAs, like that. So this is the basic objective of WAP and OMA, to bring the diverse internet content and data services to mobile phones and other mobile devices. Okay. The forum is embracing and extending existing standards and technologies of the internet wherever possible. Okay. And it is creating a framework for the development of contents and applications that scale across a wide range of wireless bearer networks and wireless device types. So whatever uh, the solutions that were proposed by this forum uh, will be interoperable, scalable, efficient, reliable, and secure. Okay, so the forum's job is to ensure that all the solutions that are offered for mobile communications are interoperable, So why it is ensuring all these things? Because to ensure that the devices are compatible. Okay, so they ensure that the solutions are interoperable. That is interoperable means allowing terminals and softwares from different vendors to communicate with each other. Okay, so the softwares and the hardwares that is made by different vendors will be able to communicate with each other. That is called as interoperable. Scalable, and the solution should be scalable in the sense the protocols and services should scale with customer needs and number of customers. As the customer need and the number of customers increases, the protocol and the services should scale. And and also the solutions are, and also the solution should be efficient in the sense the provision of quality of service suited to the characteristics of wireless and mobile networks. And the solution should be reliable. That is, there should be a provision of a consistent and predictable platform for deploying the services. And also, the WAP forum ensures that the solutions proposed are secure. That is, it preserves the integrity of user data, protection of devices, and services from security problems. So these are the so this is the job of the wireless application protocol. So basically, it is to ensure compatibility between different hardwares and softwares. Fine. So now next let us discuss the layers of WAP or the WAP architecture. So the basis of transmission of data in the WAP architecture is formed by different bearer services. WAP does not specify bearer services, but it uses existing data services and it will integrate further services. So examples of some of the bearer services or message services such as SMS, circuit switched data such as high speed circuit switched data, HSCSD in GSM, or packet switched data such as general packet radio service in GSM. Okay, so these are some of the bearer services that were that will be provided by different bearers. Okay, and WAP does not specify any such services but use the existing services that are offered by others like GSM or whatever it may be. Okay, and WAP does not specify any special interface between the bearer service and the next higher layer, that is the transport layer. Okay, and in transport layer there will be two protocols. One is WDP, wireless datagram protocol, and the other one is WCMP, wireless control message protocol. So this is the architecture or the layer of the layers of WAP. So at the bottom we can see there is the bearer service. Here we have bearer service, and this bearer service was offered by different uh, different vendors like GSM or anybody else. Okay, so WAP uses this bearer service, and there is no interface were defined for this. Then we have the transport layer. In transport layer, there are two main protocols. These are WDP and WCMP. So WDP stands for Wireless Datagram Protocol and WCMP stands for Wireless Control Message Protocol. So this transport layer provides services to the security layer. Transport layer, the transport layer provides uh, services to the security layer. Okay, through the interface TSAP, which stands for Transport Layer Service Access Point. Okay, and in the security layer there are two protocols. They are W. In the security layer there is a protocol, and that protocol is WTLS, Wireless Transport Layer Security Protocol. Okay, and the security layer offers its service to the transaction layer through the interface SEC SAP, that is security SAP, service access point. SAP stands for service access point. Okay, so mm, so this is how the interface connects with the lower layer to the higher layer. So what kind of security services it can offer in the sense, WTLS has been optimized for use in wireless networks with narrow band channels. It offers services like integrity, privacy, authentication, denial of service. So these are some of the services that are offered by uh, WTLS. And then we have the WAP transaction layer. So so the interface, so security layer offers its service through the interface SEC SAP, that is security uh, service access point. So and then there is the transaction layer, the WAP transaction layer with its WTP, that is wireless transaction protocol, offers lightweight transaction service through through the interface T or SAP. Okay. The WAP transaction layer with its wireless transaction protocol, it provides lightweight transaction service through the interface transaction SAP. Okay, so that this is the interface. T or SAP is the interface through which it provides services to the next higher layer, that is session layer. And T or SAP stands for transaction service access point. Okay? And in session layer, there is a protocol called WSP, which stands for wireless session protocol. The protocol available in the session layer is WSP, that is wireless session protocol. So this wireless session protocol of offers two services at the session shell, at the through the session through the SAP, that is session service access point. One is a connection oriented services and the other one is a connectionless service. Okay, so so these are the services that are offered by session layer. And finally, we have application layer. So session layer provides its service through SSAP, that is session service access point. And finally, the application layer, we have the protocol WAE, wireless application environment. So which offers a framework for the integration of different World Wide Web and mobile telephony applications. Okay. It offers a framework, the wireless application environment. It offers a framework for the integration of different WW World Wide Web and mobile telephony applications. Okay. So this is how the wireless WAP architecture or WAP layers were defined. Okay. And these are the protocols, other protocols that are defined in the various layers. In transport layer, we have TCP/IP and also UDP. Okay, and in security layer, there is also this protocols SSL and TLS, secure socket layer protocol. And in session and transaction layer, there is HTTP protocol. An application layer uses applications like HTML, Java, etc. Right? So that's it about the web layers. Okay, fine. So let us stop here. Thank you.